Hi guys, welcome back to my channel, and really appreciate for finding time to click on this link. So it's been quite some time before I upload new project, and today I'm here with a very important and a very complicated networking project that will help us learn a lot concerning enterprise networking project. So this is enterprise networking project 9. Financial institution, network design and implementation. Remember, in the previous projects, we've covered from project 1 all the way to the 8th enterprise networking projects. And suppose you've not accessed the classes or you've not seen the projects, I will leave a link on the description part of the video. Just click the links and start from project 1, because we normally start from a very basic enterprise networking project, and the complexity is increasing as the number of projects are increasing. Okay, so consider project 9 much complicated than the previous projects. Okay, and the complexity will proceed that way. So it's very important to start from a very basic networking project, the way that we always recommend before you come to this project. All right, another way of accessing the projects, just go to our channel, Guru Tech Networking Project, training. And the first thing to do, make sure you subscribe. After subscribing, click on the playlists. Okay, click on the playlist, then scroll, just scroll sideways, okay, until you see this playlist here, enterprise networking projects using Cisco packet tracer. So under this playlist, there are a lot of networking projects that we've done, from the first enterprise networking project to the last enterprise networking project, which was the eighth one. Okay, all right, so you just have to start from the first one, then you just move down to the 8th enterprise networking project. Okay, all right. And another thing, guys, people normally inbox me, they want this packet file, they want the documentation part. Right, you can obtain them, but if you only join the channel membership, just go to our channel and make sure you join the channel membership. Okay, make sure that you join the channel membership to get make sure that you join our channel membership to get the bucket file. But the documentation, these documentations, for example this of today, okay, if you want it, it's very simple to get. It's free. You just go to our website, which is Guru Tech, that one, that's our website, and then you come under projects. It's loading, but no problem. You come under projects. Okay, so after coming under projects, now all of these are the projects that we've done so far. I'm going to upload this to our website soon. Okay, so if you want the previous documentations, just click on any project that you want. For example, you want this hotel, the hospital system network, just click on read more, and here is the case study documentation, free of charge. Okay, but if you want the packet as a file, now you have to promote teacher. Just join the channel membership. It will only cost you around $1.4. okay, and you get the packet as a file, right? All right, so without any further ado, let's go back to our packet as a file, enterprise networking project 9. In this project, we are going to handle the financial institution network design and implementation based on the case study. And where is the case study? Where is it? I closed it, sorry. So here is the case study that we are going to dwell on today, enterprise networking project 9. So a financial institution network system design and implementation. So guys, we have a case study here and we need to read the case study. We analyze the case study, evaluate the best networking design that we can employ on this case study, and design and implement that design based on the case study. Okay, so we have a one-page case study plus one-page requirements. So it's a very a big project that we might do in two parts, but I still don't know. So let's just hope that we complete it within 2 hours time frame. Okay, all right. So Jubilee Financial Services Limited, which is JFSL, is a well-established finance service provider in Kenya, which offers online finance solutions and services to its clients. The company operates in the country's capital city, Nairobi, and is hosted within an 11-story building. The company primarily operates from the 7th to the 8th floors, where on each floor there are at least 2 departments. Okay, the company has the following 5 departments within its headquarters. So we have human resource, HR, customer service, CS, and marketing, MK, legal management, LM, and information technology, IT. The number of users and other devices per department includes, we have 7th floor where we have HR, CS, and MK department. Okay, and we see that each department has at least 40 user devices plus 40 IP phone and at least 1 Wi-Fi access point. Okay, then on 8th floor we have legal management and IT, where each department has at least 20 user devices plus 20 IP phones with an access point. And we see that each user can have an associated IP phone, but not a must. Okay, well, that means that you can just plug in a IP phone on a port, then you plug. How can I describe this? What that means, you can associate your IP phone with the computer, meaning you plug a cable from IP phone to a port, then another cable from IP phone to the computer. So it's from the computer to IP phone, then IP phone to port. It can still work, meaning we are going to implement 2 VLANs for data and voice, right, on each port. Right. The network infrastructure is currently run and managed by a third-party firm called Infinitive IT Systems Kenya. The senior management has decided to own its network infrastructure, including LAN, WAN, and an external server-side location connected via appropriate WAN technology, with prioritizing secure communication between the HQ network and the external site. The server-side site will host DCP, DNS, web, and email servers. The company is intending to subscribe to 2 ISPs. In bracket, you have Safaricom and JTL ISPs to provide redundancy and load balancing in terms of internet provisions. The company has also purchased 2 Cisco Catalyst 2911 routers, one for HQ and another for server side, plus 1 gateway router, Catalyst this one for HQ voice over IP, okay, services, telephone service, and 2 multi-layer switches, both for HQ. Okay, HQ will have two multi-layer switches and 6 access switches for the departments. Remember, here we had 5 departments. Okay, so the 6th one I think is the other one on the server side. Okay, all right. So due to the security requirement, it has been decided that all the 5 departments will be on a separate network segment within the same local area network. None of the servers is located within the local area network, but will be hosted from an external site accessible via a WAN connection. The network security policy will comprehensively dictate the user access to the external site using access control list, ACL. Okay, you've been hired as a network security engineer to design the network of Jubilee Financial Services, or JFSL, according to the requirements set by the senior management. You will consult an appropriate robust network design model to meet the design requirement. You will also implement access control lists and virtual private networks to enable secure communication, considering security and network performance factors paramount to safeguarding the confidentiality, integrity, and availability of data and communication. So this is a very important project, guys. It's a very important, guys, for the career development. Very important, you know. Okay, so let's move to the requirements. The requirements. The company has emphasized high performance, redundancy, scalability, and availability, and hence you are required to provide a complete JFSL network infrastructure design and implementation. The company will be using the following IPs. This one for data, okay, this one for voice because we have IP phones, and this one for public IP address. This is now for ISPs, okay, public IP addresses. Right. So requirements, sub requirements. From number 1, design tool. We are required to use Cisco packet tracer to design and implement the network solution. Very important. Hierarchical design. Use hierarchical model, providing redundancy at every layer. Okay. ISPs. The network is also connected to is also expected to connect to 2 ISPs to provide redundancy, and each router is connected to the 2 ISPs. Good. Wi-Fi. Each department is required to have a wireless network for the users. Voice over IP. Each department should have IP phones, and the users in the department should be able to call each other. Good. Each department should be in a different VLAN and a different subnetwork. The voice VLAN ID number will remain at VLAN 20 for the entire network. Okay, so this means that all the IP phones will be in VLAN 20. Alright, in the network. Okay, subnetting. Provide the networks above. This one. Provided the networks above, carry out subnetting to allocate the correct number of IP addresses to each department. Basic settings. Configure basic settings such as hostnames, console password, enable password, banner messages, encrypt all password, and disable IP domain lookup. Okay. Inter-VLAN routing. Devices in all the departments are required to communicate with each other with their respective multi-layer switch configured for inter-VLAN routing. Very important. Core switches, all the multi-layer switches. The multi-layer switches are expected to carry out both routing and switching functionalities, and thus will be assigned IP addresses. All devices in the network, except IP phones, are expected to obtain IP addresses dynamically from the dedicated DCP servers located at the server-side site. Okay. So as you can remember, there was a concept of a voice gateway. So the voice gateway will be responsible for providing IP phones and IP addresses. Okay. But for all the other devices, we have the dedicated DCP server at the server-side site. Okay. So Cisco 2811 router. Okay, ensure to have a router that can support telephony service. Very important. Currently in packet tracer, this is the router that can support telephony service, i.e. Cisco, that one. Then we've been told that the router, the voice over IP router, or the voice gateway should be connected to any of the layer 3 switches at the HQ. Okay, so what's that connection? Well, we're going to see during the design. Static addressing. Devices in the server room are to be allocated IP addresses statically. Very important. Telephony service. Configure voice over IP on the voice gateway router and allocate dial number in the format 4 ... Okay, so it's like 401, 402, 403, all the way to 499 of all the IP phones in the network. Okay. Routing protocol. Use OSPF as the routing protocol to advertise route both on the routers and monthly switches. Switchport security. Configure switchport security on the server-side department switch to allow only one device to connect to a switchport. Then use sticky method to obtain MAC addresses and violation mode of shutdown. Very important, very important. I really like this project. SSH. Configure SSH in all the routers and layer 3 switches for remote login. That's very important. Standard ACL for SSH. Wow. Configure simple standard access control list on the virtual interface to allow only ICT department to carry all the remote administrative tasks using SSH. Wow, this project is a very, very important project. NAT plus ACL. Configure part to use the respective outbound router interface IPv4 address and implement the necessary access control list. And very important NAT is because we have ISP, so we have to use NAT. Point 20 IPsec VPN, wow, plus ACL access control list. Configure site-to-site IPsec VPN between HQ router and the server-side router and implement the necessary ACL rule. Very important, guys. Finally, test communication and ensure everything is working perfectly fine as expected. Wow. So guys, this is a very big project. This is a very, very big project, a very important project. And as you can see, there's a company actually that is it's a finance service provider in the country called Kenya, and the company is located in the capital city, and it's operating from 7th to 8th floor. So it has how many departments? 5 departments on the HQ network, and on the other side of the server side there's only that one department, server side department. Okay, and we have been provided with everything that we need to start the descent. So guys, without any further ado, this is a very big project. Let's go back to our packet tracer and start the descent part. Okay, so depending on the case study here, we've learned that there are some devices that have already been purchased. For example, the company has subscribed to ISPs, and also the company has purchased these routers. The company has purchased this one gateway router and 2 multi-layer switches for HQ and 6 access layer switches for the departments. All right. So basically, what I'm going to do, I'm going to start with the SP routers. So for SP routers, let me just choose 2911 router, and I put it somewhere here, 1 and 2. Okay. All right. So after doing this, I'll go back here and learn about the HQ network. We've been told that there are 2 routers. This one for HQ, another one for server side. So I go here, I put one for HQ, 2911 router still. So let's assume this is for HQ, and another one for server side. Let's put it somewhere there. Okay. All right. And then when we move down just a bit, somewhere here, somewhere there. Okay. Then when we move down here, we see that there's one gateway router, this one for HQ voice over IP, this router. So for this router, I'll kind of pause it, I'll do it later, and let's move to layer 3 switches for HQ. Okay, so we need 2 layer 3 switches for HQ. I put 2 layer 3 switches for HQ, and for layer 3 switches, I just click on the switches, you choose 3650 switch. That's one. And another one is here, somewhere there. Okay, right. Then we've been told that there are how many access layer switches? 6 of them. So as you can remember, in the HQ department, in the HQ network, we had how many departments? 5 departments: HR, CS, MK, LM, and IT. So, and on the server side, so we need 5 departments, 5. So that's the first switch. Put it there. Okay. So what's remaining here is just connection. I'm going to use serial connection between these routers and the ISPs routers, okay? But the normal connection between the routers, multi-layer switches, and the switches, okay? And as you can see here, we were told that, where is the ISP side? They were told that each router is supposed to connect to 2 ISPs, at least 2 ISPs, okay? All right. So what we're going to do, we are going to use serial connection between the institution routers and the ISPs, be it the HQ or the server-side router and the ISPs. So by default, these routers don't have a serial module, so we need to add them. So just click on any router, then you turn off the router. There's a button here. Just click on the button, turn off the router, and add this module, HWIC-2T. Drag it and place it there. Then turn on the router again. Do the same for the remaining routers. Okay, I've managed to insert serial modules on the routers. So what I do is just connect them. Just click automatic cable connection. Click on the first the HQ router to first ISP. Then click on the HQ router again to the second ISP. Then choose automatic still from this router to the ISP. Also from this router here to the ISP. Okay. Then let's connect the HQ network. Just use connection the way you like it. Okay, so I've managed to connect the devices, the intermediate devices, the switches, and the multi-layer switches, and the routers, and the ISPs. So I left one point here about I left one point about yeah, this one gateway router for voice over IP 2811 router. Okay, and there was something here that was listed. I just want to show you it. Ensure that the router can support telephony service, example this router. Then we are being told that the VoIP router should be connected to any of the layer 3 switches. So I don't know how it's going to be, but we can just for example, let's choose that router. Let's take that router, 2011 router. Here it is. Okay, all right. So we're being told to connect it to any of the switch multi-layer switches. All right, so let's just connect it there, and that's just done. Okay, so can we put it inside somewhere there? Although our design is going to look a little bit bogus, but it has to be there for telephony service, because it's the only router that is responsible for providing that service on packet tracer, and we can't use this router because it cannot provide that service. Okay, so let's just go according to the instruction, which is very important. Oh, I choose the wrong router. Is this 36? This switch should not be here. we are supposed to choose 3650 switch, but this one is 3560. I chose the wrong switch, so I'll put this one here, take that one from that point, I plug it in there, and what I do, I just delete this switch and reconnect all of them to the switch. Okay, so that's done. Now the next thing that we do, let's turn on the switches. Just drag in power supply, that's all. Come to this one, drag on the power supply, that's all. All right, so let's go to the to the end devices. Let's go and connect the end devices. We should now connect the end devices. So for example, being told that each department should have a Wi-Fi network, an IP phone, a printer, computer, you know, those kind of devices. So for example, here I'll just come, then I put for example two computers like that one, somewhere there. And remember, this network we can use both. We are going to use two VLANs, one for data and one for voice, and we can associate each PC to IP phone. Okay, then for wireless, sorry, I forgot to take printer, so up here I delete that, I put printer. Okay, so we can either associate IP phone to computer or just leave the way we were told. That means you connect a cable from the switch to IP phone, then another cable from IP phone to the computer, although it's connected to one port. So that port should provide both data and voice traffic. And then finally we need an access point to connect let's say laptop. We want laptop, we want tablet and smartphone. Okay, so we provide wireless access point IP, the first one. Okay, put it somewhere there. All right, so what should I do? I just need to connect them, all of them. For example, connect that to that. I do them very, very fast to save time. Okay, so now for the laptop, you know, if laptop doesn't, the Paketesa laptops doesn't have a Wi-Fi card by default, so just have to insert that module. Just turn it off until you see the yellow icon is gone. Then drag out that module until you see here is black. Then drag this WPC what and what. Okay, then turn on the laptop again. Okay, then I don't want this devices to connect right now, so I'm just going to change password because the password is default. So I'm just going to change it something like that so that they don't connect. Good, I don't want them to connect right now. So guys, we are going to copy these to all the departments, to the remaining 4 departments. Before that, let's turn on let's put the power adapter to the IP phones. Good, you can see my setup is quite clear. You can see my setup is quite clear. Okay, you can use one port for IP phone and computer. Okay, all right, any of them. Good. So what I need to do, just to copy. I'll just copy, paste, and do the necessary. So I'll do it very, very fast, save time. I copy, I paste. Now I drag it to somewhere here. I believe that's the right thing. Yeah. Okay, so I've copied and pasted all the devices. As you can see, each department that is it's at least having the required devices. So I just do the connection very fast, save time also. Okay, so as you can see, I've included all the devices in every department, and every department is having at least the devices that are required. Um, so let's do for server side. Server side, we had four servers. Okay, so I think our design is a little bit complete. Now what you just need is to make it beautiful, do the naming and the borders. So what I'll do, I'll first do the naming. For example, ISPs, HQ router, server-side router, HQ multi switch 1, HQ multi switch 2, and so on, so forth. So this one was Safaricom. Okay, now for the switches, we name them as per department. For example, this HR department switch. So I'll just say HR depth or HR switch. Okay, guys. So I've done the naming of all the devices in the network. For example, these are the IP routers. We were told that there are two IP routers. This one, Safaricom and JTL ISPs. So this is Safaricom, that's JTL ISP, and this is HQ router. This is our side router. And in terms of multi-layer switches, let's say HQ multi-layer switch 1, HQ multi-layer switch 2. Then this is HQ VoIP router. We were told to attach it to any of the multi-layer switches. Then for the access layer switches, you can see HR switch, CSS switch MK, LM, which is legal management, and IT switch. In terms of host devices, you can see clearly we have, for example, a PC in HR is called HR PC, a printer at CS is called CS PC, IP phone at MK department is called MK phone with the number 123, and an access point at legal management department is called LMAP, and the naming is consistent and kind of very identical per department. And these are devices also, IT laptop, IT smartphone, things like that. Okay, all right. So basically what's remaining is just to divide this network to show that this is HQ network, this is server side network. Okay, all right. So just a minute. Okay, so I'll proceed and divide this network as HQ and server side network. So I'll just take that first and minimize it so that it become I zoom out so that it become that one. And what if I just a little bit. Okay, it's still big, so just do that. Okay, then I take that and I start doing this now. Okay, so I just do reset. Okay, now it's okay. All right, so that's HQ network. And remember we had how many departments? And we had 2 floors, 7th floor and 8th floor. So the 3 of these will be on 7th floor and the 2 of these will be on 8th floor. So I just do this. Just want to name them. I just want to name here as what was the company? It was Jubilee something. Jubilee JFSL. So I just say this is JFSL HQ network. Then when I come here, I'll say this is JFSL server side network. Okay, so and I give it a very bright color. What I do now, let's separate 7th floor from 8th floor. Now let's separate 7th floor from 8th floor. Just do a little bit of that. Okay, the 3 of these should be on 7th floor, the 2 of this 8th floor. So I still take that one and say no fill, and I run it this way. The 3 of this to be 7th floor. Okay, somewhere there, and the 2 of these to be 8th floor. Yes, no problem, that's okay. All right, so on the 8th floor we had before that, let me just comment here as 8th floor, it was JFSL 8th floor, and copy. I come this 7th floor, sorry, 7th floor, and this JFSL 8th floor. Good. Now same thing, I give them a bright color. I want to give them that one. Oh no, fill. Yes. Okay, so also in each on each floor we have departments. So let's separate the borders of each department. So to do that, we're not going to use too much bright colors, but oh, I did the fonts are left. So it will force me to drag it a little bit somewhere here so that these devices are accommodated, although it's not no problem. I'll just leave it at that point, although these devices are not inside the circle, but no problem. All right, so let's separate the boundaries of each department. So for example, this is HR department. I'll do it very fast, save time. Okay guys, so as you can see, I've given a background color for each department so that they can be easily identified. So it's not that much bright colors, so that's pretty much okay. And now what I'm going to do, let me give color for this department also, for server side department. So for server side department, I'm going to give a circle with green color. Yeah, green color is okay. Too much green is not okay, but yeah, that kind of green. So we just give a circle like that. Okay, so I'm going to give a description of each LAN of each department. So give the name, and I'm going to give the name. Yes, I'm doing that so that I can find space to write the names. I'm going to do reset. Good. Okay, so everything's just looking perfectly fine. Now, okay, for example, this is HR department, so I'll just say HR dept, HR department, and I copy, paste this one to be CS. Okay, so I've named all the departments, so the design is looking perfectly fine. Very good, you know, very well. And also this side, let's name it as server side. Side LAN. Okay, that's okay. And for the ISPs, let me give colors for the ISPs, something like a circle, background color. And which color should I use? Okay, so here I will name as ISP. I'll name as ISP area. ISP area. Okay, all right. So I think our design is complete. So what's just remaining is just some comments, some additional comment. Don't worry, although this is making our design to look a little bit not much beautiful, but it's okay. We're just following instruction. We were told to attach it to any of the multi-layer switches, and that's the thing that we've done. We're following instruction. It's okay, perfectly fine. Okay. All right. So let me go back to our case study. So this is the case study that we read earlier, and as always, my culture, I normally highlight the step that you are going to follow when we are doing any networking project, and here are the steps that I listed. Network design and beautification. Network design and beautification, very important. We've done that. As you can see, we've done what's called network design and beautification. We've designed everything, and we've beautified the network such that it has different colors for identity and for differentiating departments, devices, floors, etc. Okay, and basically now the next step to go is we are going to start configuration, basic settings to all devices, plus SSH on the routers and layer 3 switches. So let's go back to our case study. Basic settings. We are told basic settings, just some. Okay, configure host names, console password, enable password, banner messages. We need to encrypt all the password and disable IP domain lookup. Very important. And as I always do, we do configuration on one device, then write commands on a notepad and copy to all other devices. Very important, you know. And so I'll begin with the access layer switches to configure basic settings. And among the basic settings that we're going to configure listed here. So these are the basic settings: host names, console password, enable passwords, banner messages, encrypting all password, and disable IP domain lookup. So let's do the configuration on this switch for a demo. And now for the remaining switches, just write no commands on notepad and copy to all other switches. So enable config t. After config t, we just write hostname as this is HR depart, so just write HR hyphen switch. Okay, and another thing we do, enable password. Enable password is the enable password listed here really, and it should be there. Enable password is very important. Enable password for privilege exec mode. Enable password, our enable password is here, and line console password. So I'll start with enable password. Enable password. In my configuration, I always use Cisco as everything, be it username or password. Okay. Sorry, enable password to be Cisco. And line console, we need to configure line console password, so just enter that line console console 0. Then we just issue a command called password to be Cisco. Okay, then we log in the user, we authenticate the user, then exit. Are there any other thing that has been listed here on okay, that's all exit. Okay, and another thing is banner message, so just write banner MOTD message of the day, then any character, let's see, just use this one, then inside that character just say no unauthorized access. That's all. Okay, hit enter. Another basic setting that we need to configure is no IP domain lookup and encrypt all the passwords. Just say no IP domain lookup. That's all. And now we encrypt all the password that you just configured. We just say service password encryption. That's all. And what's remaining on the basic settings, we've just done hostname, console, enable password, banner messages, encrypting, and disable IP domain lookup. That's all about basic settings, and what I just say, do right. Okay, so we're done on the first switch. So I want to copy this message of the I want to copy this no unauthorized access so that I'll paste it later. Copy that. Okay, so it's the time to write commands on notepad and copy to all other remaining devices. So just write enable, then config. The first thing, hostname. For this case, this is CS switch. Then what we do now, enable password. Make sure that you type correct English. Enable password to be Cisco. Okay, then line console 0, console 0, then password to be Cisco 2. Then we log in the user, authenticate, then we exit the line interface. Okay, all right, then what's up, banner message, banner MOTD, then the two characters, then inside the two character I paste the message that I just copied, right? Then what's remaining here now, disable IP domain lookup, no IP domain lookup, just like that. And what's remaining also, encrypting the passwords. So there we use a command that's called service password encryption. Make sure your English is correct. You write correct English. Encryption. Okay, encryption. Okay, that's okay. Then do right. Okay, so I'll just modify hostname for all the devices and copy to all the devices. Okay, I just modify hostname for all the devices, so I copy first for CS switch. Okay, so I've done the basic settings on all the access layer switches, and definitely I'll move to the distribution layer switches. And as you can see on the config guide, we were told to do basic settings on all the devices plus SSH on the routers and layer 3 switches. So what am I going to do? I'm just going to copy these commands. For example, I'm just going to change this as HQ mat layer switch 1, HQ exhaust name mat layer ML switch 1. Okay, switch 1, and I copy everything, I come and paste to this switch here. Okay, now we've done the basic settings, but we were told to add SSH on the routers and the L3 switches. So let me write let us configure SSH on this mat layer switch. The first step to configure SSH, ensure you configure host name. So the first step is to configure hostname. When you want to configure SSH, make sure you configure hostname. Then the second step, make sure you configure username and password. Hit enter. Third step, you configure IP domain name. IP domain name to be, let's say, cisco.com. Okay, and you hit enter. And now is the time to generate crypto keys. Crypto key generate RSA, and you hit enter. And then how many bits in the modulars? Let's use 1024. Okay, very important. Okay, you will see the name of the keys will be hq.matless1.cisco.com. okay, this one, the domain name that we just listed. Then you just hit enter. Okay, now SSH is enabled, so let's give SSH a version. Just say IP SSH version 2. Sorry, IP SSH version 2. Okay, give it a version. All right, so we've just generated a crypto keys and given SSH a version. So it's the time to bind this SSH to a VTY interface. Okay, although it's configured, but we've not applied it on the VTY interface. So let's do that. Line VTY 0 to 15. Okay, then we say login local to use the local database. Login local to use the local database. Then transport input only SSH, because we've been told to configure SSH. We don't want to input all, because when you input all, even telnet will be used, but telnet is not secure. So we just say transport input all, I mean SSH, sorry, and you hit enter, exit, and do right. So we've configured SSH on this multi-layer switch. Okay, so I want us to write SSH configuration here, because the basic setting will be just similar to all the devices. So I change this to that one, multi-layer switch 2. Then I proceed down. Here to write SSH configuration. The first thing that we have to make sure that the device has source name. Then the second thing, create a username and password. So username Cisco, and the password of Cisco. Okay, the third thing, create IP domain name. IP domain name, let's cisco.com. Okay, very important. Then let's generate crypto keys. How do you do that? Very important. We just say crypto key just a minute. Crypto key generate RSA. Then we hit enter and it will prompt us how many bits do we want to use. We hit enter, then we say 1024 bits. Okay, all right. So that will enable SSH. After SSH is enabled, we give the version of SSH. We just say IP SSH version 2. Okay, all right. So SSH has been enabled with the version 2. So it's the time to apply them to the interface. So we just say line VTY 0 to 15. Okay, then we say login local to use the local database. Okay, then transport input SSH. Transport input SSH basically means the VTY interface should only use SSH as the method of remote access, then exit. Good. So I believe this will work, and I just have to copy. But when I come to the routers, I just change the host name. Okay, very important. So I'll do it very, very fast to save time. For example, I'll click here, I come to CLI, and I just paste. Right, no error, meaning it was perfectly configured. I wrote correct English. The problem might come when you don't write the correct English word. Okay, all right. Okay, so I've done the basic setting plus a search on all the devices in the network, access layer switches, multi-layer switches, and the routers. Okay, all right. So let's go back to our config guide to see what's the next step. Okay, so the next step is to configure VLANs, for example, for data and voice, plus all access and trunk ports on layer 2 and layer 3 switches. Okay, all right. So guys, as you can see, we need to configure VLANs. So before that, for example, let me go back to the case study. I saw something of VLAN assignment. Okay, this one. Each department should be in a different VLAN and a different subnetwork. The VLAN ID number will remain VLAN ID 120 for entire network. The voice, the voice should remain VLAN ID that one for the entire network. So any VLAN of IP phone should be 120. Okay, all right. So let's say I just want to do a quick comment. The VLANs will be only applicable on HQ network, not the server side. Okay, all right. So I'll just do a quick comment. I mean, for example, I'll just say VLAN. I want the data VLAN on HR department to be VLAN 10. So I just say VLAN. Okay, then I hit enter. Data to be 10. Then voice we were told to 120 for the entire network. Okay, 120. So I'll just copy this and paste in all the departments. Now I change here to 20. Okay, so as you can see, the VLANs have been listed there as the comments, and you can see each department as a different VLAN. Not only for, only for voice VLAN is the same in all the departments. Okay, so it's upon us to configure this switch. So it's upon us to configure every switch to have both data and voice VLAN. Every port on a switch should be associated with the two VLANs, for data and for voice. So pretty much simple, you know. The first thing to know, identify trunk ports and access ports. We only configure the VLANs on the access ports. Okay, all right. So let's come to the switch here. I normally do my configuration in a orderly manner. So the first two connections should attach to first 0 1 faster than at 01 and faster than at 02 on all the switches, so that when I write the commands on notepad, it's consistent in all the switches. So for example, if I hover over this, you see is FA01, FA02, and the same case applies to this, all of this. I normally do my things in a orderly manner, okay, so that I have consistency with the interfaces. Okay, it's the same in all the devices. Okay, so I come to this switch first. Oops, it needs password. Cisco. I'll not enter the password. Just come to config and click any interface. I come back here and exit. All right, so it's at the time to assign VLAN numbers to interfaces. The first thing that we do, we create the VLANs. After we have identified which ports are trunk and which ports should be accessed, now we create VLANs. Okay, now let's say VLAN 10. Let's name it data, give it caps. Okay, then VLAN 120. Now VLAN 120. Okay, name to be voice. Okay, good. Then we exit. Then let's assign ports roles of trunk or access. Okay, for example, the first two, the way I said, the first two are trunk because you can see they're connected to other switches. Okay, they should be trunk, right? Because they will be passing multiple VLANs. They cannot be accessed because access can only access one VLAN at a time. So they only be passing multiple VLANs. So we need to make them trunk. So interface range FA0/1 to 2. Okay, then switch port mode trunk. Hit enter. Very good. Exit. Now we are done with the two interfaces. So let's go back to the access interfaces. So for the access interfaces, it should range from interface range FA0/3 to 24 because these switches have 24 ports, but the first two ports have been taken by a trunk. So let's assign the remaining ports roles of access. Okay, interface range, that one to that one. Okay, very important. And hit enter. No, it should be from 3, not 2. 3 to 24 because 2 should be trunk. Okay, 2 and 1, FA1 and FA2 should be trunk. Now from 3 to 24 to be access. Okay, then we say switch port mode access. Okay, then we have VLAN 10 and VLAN 20. Now first thing, let's assign the data VLAN. How do we assign the data VLAN? Very simple. Just say switch port access VLAN 10. Very simple, and we just hit enter. Okay, very simple. Then how do we now assign the voice VLAN? Very simple. Just say switch port voice. Now we start with the voice VLAN 120. How do I send data VLAN? Switch port access VLAN 10. How do I send voice VLAN? Switch port voice VLAN 20, and hit enter, exit, and do right. Okay, do show start. You will see FA01 and 2 are trunk the way we expected, but now from FA0/3 to 24 you can see a interface switch port access VLAN 10, switch port mode access, then switch port voice VLAN 120. Now that's pretty much okay. Now is the time that now we write commands on notepad and copy to all the remaining switches to save time. So I open notepad. What did we do? The first thing was to create VLANs. I just create VLAN 20 now for CS department. And I name it data. Okay, then VLAN 120 also I name it voice. Okay, all right, exit the VLAN interface first, Now we go back to assign ports roles of trunk and access. For example, this one should be trunk. Okay, so I come here and say interface range fa 0/1 to 2. Then you say switch port mode trunk exit. Be very careful when you're writing your English. I'm normally perfect when I'm writing English because I'm from Kenya, and the Kenya we speak Queen's language, the British English. So it's very important to write the correct English word. Okay, all right. So the two are now trunk. Okay, so it's upon us to assign the other remaining ports the role of access and assign them VLAN numbers, both for data and voice. So another range. So I'll just try to copy this. I'll copy that, and let me just copy all of it. And interface range now from 3, okay, from 3 to 24, because we have 24 ports. Switch port mode access now, okay, right? Then switch port access VLAN 20. We created VLAN 20 here, okay, for data. Then switch port voice VLAN 120. Very important, very important. Then we're just done. Do right. Okay, now what we will change for the 3 remaining switches, just the VLAN, the VLAN ID here and here. Okay, everything will just remain the same. So I'll just copy and go very fast without wasting much time. Okay, so guys, I've managed to assign all the ports the roles of access and trunks, and assign the access ports VLAN numbers, both for data and for voice. So it's okay. Now let me see additional information on the config guide. Access on layer 2 and layer 3 switches. Okay, so now it's upon us to go to layer 3 switches. Now for layer 3 switches, we're going to be very easy. We just identify which ports should be trunks and which port should be access and which port should be a layer 3 interfaces. So let me discuss this. On the 2 multi-layer switches, we are only going to have 2 roles. For example, this port will be a layer 3 interface, okay, no switch port. It's going to be assigned IP address. So, okay, so as per now we are not going to interfere with it, okay, and also this one. But for the remaining one, this one and this one, to be trunk, and also this port is going to be trunk, okay, because we want it to pass a voice VLAN to this HQ voice gateway. So when we are configuring a trunk, we are going to consider this interface, and this interface, okay, all of these, but not this one, okay. In this case, all of these interfaces, but not this one. The reason why I want to configure this interface as trunk, although it's connected to another router, is because I want this to pass the voice traffic to this router, because this router will act as the default gateway of all the IP phones in the network, okay. So from this point, all of this to be trunk, okay. So let's do that. So for example, that's the gig 02, this gig 07, 3, 4, 5, and finally 6. So from gig 102 to gig 107 should be trunk. gig 102 to gig 107 should be trunk. Okay, and I want to put password. So as I said, interface range, it was from gig 10, gig 102, gig 1 slash 02 to 7. Okay, switch port mode, because this is gig 11, gig 11. Okay, switch port mode, trunk, and hit enter, exit. Now let's create the VLANs, all the VLANs in this switch. So it's very simple. I'll just go here, for example. Now I'll create VLANs. Sorry, now let me just do it here. That will be tedious. That's why I have this notepad here. So for example, I want to create VLAN 10, and we name it VLAN 10. Now we name it as the department HR. Okay, then we create another VLAN 20. We name it as the department. We name it as CS. We create another VLAN 30. VLAN 30. We name it as the department, which was marketing MK. Name it as MK. We create another VLAN 40. We name it as legal management, LM. Then finally VLAN 50. Then we name it as IT. Okay, so, and we create VLAN 120 for voice. Okay, all right, so I'll just copy all of these, to this switch here. Okay, so do right on that switch. So we are done with this switch, so let's go back to this multi-layer switch and configure trunk interfaces. So the trunk interfaces, exit. So the trunk interfaces here are from this one, which is gig 02 to here is gig 06, because here had additional interface that was connected to the VoIP router. Okay, so interface range gig 1/0/2 to 6. Switch port mode trunk. Okay, exit. Then we paste the VLANs that you just copied. This one. Okay, I just paste them there and do right. So it's okay. In terms of VLANs on multi-layer switches and access layer switches, we are done. So let's go back to see what's next in the config guide. Switch port security to server side department. Wow. Switch port security to server side department here. So being this external department, we don't want any other device to connect to those ports apart from our devices. Okay, all right, so we are going to configure switch port security to this switch here. Okay, so this is switch interface, this one FA01. So from FA02, that one FA02 to FA05, we should configure switch port security there. Okay, and how do we configure switch port security? Very simple. Exit. The first thing we do, we check on the documentation, the requirement. Switch port, yes, switch port security. Configure switch port security, this one. Configure switch port security. Configure switch port security for the server side department switch to allow only one device to connect to a switch port. Use sticky method to obtain MAC address and the violation mode of shutdown. Okay, so we said that ports are, the first thing we do, we check the interesting interfaces, the one that are connected to this one, the one that are connected to the devices. Okay, and because this is an external server side, someone can infiltrate and plug their own devices. So we just want to say interface range FA0/2 to 5. Then we just say switchport mode access. Okay, just a minute. Then after making them access ports, now we initiate the process of configuring configuring switchport security. We just say switchport port security, port security, that's all. Then switchport port security maximum, we've been told to allow only one device to connect to a port at a time, maximum of one. Okay, right? Then switchport port security MAC address to obtain through what command? Sticky command. Here the instruction, where is it? This one. To allow only one device, we've done that, and use sticky method to obtain MAC address and the violation mode of shutdown. Very important. MAC address to sticky command. Okay, and hit enter. Then switchport port security violation mode to be shut. Okay, exit and do right. So guys, we've secured this switch. Okay, but what if someone comes and plug a device to the port that you've not secured? So you know that's the security principle there will be broken. So we need to there are other ports that are connected to this that are not connected to any device and they are not secured. So you know, when you try to plug in any device, the port will turn up. So maybe an attacker might plug in a very malicious DCP server to that port. So we need to turn off all those ports that are not connected to the servers. Okay, so interface, for example, you can see here, these are the only ports that are connected to the servers. Okay, this one. Okay, so from 06 to 24 are not connected to the servers. So interface range, before that do show start. So you can see from 6 to 24 they are not connected to anything. Okay, and the other ports from these two ports, gig 01 and gig 02. So I'll just say interface range FA0/6 to 24. Okay, and another range of gig 0/1 to 2. These two. Okay, we want to shut them down and assign them to a very strange VLAN, so that and that VLAN, we will not allow communication with that VLAN. So even if you plug in any device, that VLAN is not allowed for communication. Note the traffic will be blocked. Okay, we hit enter and just say switchport mode access, then switchport access VLAN 90, let's say one, that's 99. That's kind of a very fake VLAN. Okay, and shut down, we want to shut them down. Good, exit, do right. So we just say do show start. So we'll see from port 6, you see from port 6 to all the way to 24 until you reach gig 01 and gig 02. They are in shutdown state and they have been assigned a VLAN 99. We are not going to allow a communication of any VLAN 99. So even if an attacker comes and plug a device to any of the ports, you know that port is by default in shutdown state and it's in a VLAN that cannot communicate. So this server side department is secured. Very important, guys, very important. So, and if you go up, you can see from port 2 to port 6 they have switch port security, okay, with a maximum, sticky method of obtaining MAC address. And in fact, I can just say do show port security. You will see how many ports have been secured. Only 4, from 2 to 5, and we can see only one device can connect to a port at a time, and the violation mode is shut down. So very important. Okay, that's done, guys. Very important method of security. All right, so another step that we need to do is subnetting and IP addressing. So IP addressing and subnetting, very important, but you know, subnetting normally takes a lot of time. We were given block networks here. For this one is for data, this one's for voice, and finally this one is for the public IP address, the ISPs. So I took my time in the background and did subnetting and came up with this table here. Okay, so this is the table that we're going to use. For example, a SR department will have this network and a separate mask. So for the valid host IDs will be this one, the default gateway should be this one, and the broadcast ID should be this one. So the same applies to all other departments. So if you want to use this addressing table, you can just screenshot this page and use it the way you like it. And now the server side will have this addressing plus the subnet mask network, and this one should be network and IP subnet mask. Yes. And now between the routers and the layer 3 switches, you can we are going to use this one, and between the routers and ISPs, we are going to use this one. So guys, without any further ado, I'm going to start commenting on the networks. Okay, so for example, the HR department is going to have that network, CS, MK, MLM, and between the devices, for example, routers and layer 3 switches, and the routers and ISPs. So I'll start with the departments. So I'll just go to the design and give a comment. For the network of the voice, I didn't include it here. I didn't include it here because I'll just write it somewhere here, because it was just given for a full one block, okay, for all the devices in the network. So irrespective of which device is in which department, they will have IP address from this router. They will be the same subnet. All the devices, all the all the IP phones in the network will be the same subnet. Okay, so there's no need to subnet it. Okay, so I just do that and comment here. For example, this one is net to be 192.168.20.0/26. Copy. Oh, this one should be capital. All right, so I think my subnetting is perfectly fine, because we were told that HR, CS, and MK department should have at least 40 devices. So you can see a /26 notation provides how many addresses? IP addresses 62. So 62 can accommodate all the 40 addresses. And we are also told that loan management and IT department should have at least 20 devices. And slash 27 provides that 30 IP addresses, and 30 IP addresses can accommodate 20 addresses, so that's okay. So I'll just go very fast, save time. Okay, so I've done the comments on the departments. You can see from HR department, CS and MK, they have slash 26. Okay, but LM and IT, they have slash 27. Right? Okay, so let's go to server side department. I'll check on the IP address of the server side department and command it. This one, copy, and come this side. Okay, now what's remaining on terms of IP addressing? Oh, the network between the routers and the layer 3 switches. So I just copy HQ and multi-layer switch 1. Do it very fast. And now what's remaining? The network between routers and SPs. You do it very fast. Okay, so I'm done with the comments of network teach department and between the devices. So for voice over IP, I just want to make it a color first. And then IP net to be net was we were 110.10.10.0/24. Okay, that's voice gateway. So guys, basically I've done the comments based on the IP addressing scheme and the subnetting results that I did earlier based on these tables. So the only thing that's remaining is to assign IP address to the interfaces. Very important, you know. So how am I going to do that? So I'll start from the multi-layer switches, or I'll just start from this router here. So this router, the interface of this router, oh sorry, first Ethernet 00. So the first thing I do to first Ethernet 00, I turn it on, or I just do go using CLI, no short. Now it's on. Then I send IP address, paste that, change it to 1.255.255.255.0. Okay, exit. I think I need to do something. Yes. You know, before I do that, the voice traffic as a VLAN. Now we must create inter-VLAN routing on this router for it to work. So we are going to create a sub interface and assign it this IP address, not this interface. So I should create a sub interface. Just say no IP address first. Good. Now I create the sub interface dot 120. Okay, for voice traffic. This now high level. I didn't think I should do it at the lower level. I should have done it. I should have done it later, but now because I've started it, let me just finish it off. This now for voice traffic. It should have, associate the VLAN number. Okay, then we just say encapsulation dot 1q 120 for VLAN, for voice VLAN. Okay, then we assign it that IP address and exit and do right. Now we are done assigning IP address to that interface for voice. This is a very delicate router here, because if you mess up with it, the IP phones are not going to work. So the first thing to do, because we know IP phones are assigned VLAN 120, now you create a sub interface for inter-VLAN routing and assign it encapsulation.1q the VLAN IT, and you assign it IP address. Okay, and if I try to move over it now, you should see first Ethernet 00.120 with that IP address. Okay, so let's assign IP address to this interface first. Gig 00. Interface gig 101 IP address. Sorry. Make it a layer 3 interface first. Make it a layer 3 interface first. How do we do that? No switch port. And you hit enter. Okay. And we are sending the IP address of put it somewhere here, 192.168.21.17, because the network is .16. Okay, so that mask of API, so that mask of 255.255.255.252. Okay, no shut. Do right. So we're done as configuring IP address to this interface. Now let's do it for this interface, which is gig 11, gig 10, gig 01. No switch port first, and IP address 192.168.21.21 255.255.255.252. No shut. Do that. Okay. So guys, I'll proceed to configure IP address to the router's interface very fast, save time. So I think you have mastered how I do it. This one took 21.17, this one took 21.21, so this one should take 21.22, this one should take 21.18, this one should take 100.5, this one should take 100.1, this one should take 100.2, 100.6, and so on and so forth. So I'll do it very fast to save time. So it's upon you to know how to configure it correctly, because it's very simple. I have specified the network between them. Now make sure you did it correctly. Okay, so I'm done sending IP address to all the interfaces. So I'm just going to check them. Okay, they're okay. Everything is okay. Everything's looking perfectly fine. So I'm done configuring IP address to all the interfaces. So it's upon us to check on what's next on the config guide. I'll go to the config guide, open it, OSPF on the routers and the layer 3 switches. Wow, very important, very important. So we need to do OSPF on the routers and the layer 3 switches. So I'm just going to go to this switch, because this switch and this we're going to advertise the same, almost the same network, only this one and this one will be different. So I go to this switch first. Okay, now this is a multi-layer switch, and the first thing to do before you do any routing is to enable IP routing. How do you do that? Just write IP routing. That's done. Come back to this switch also and enable routing. Just say exit, IP routing. That's done. So let's advertise networks. Let's advertise networks. So in this case, guys, I'm going to do what's called route summarization. I don't want to advertise too many networks. What I want to do is just to do route summarization, because this network here, this one, this one, this one, this one, can be summarized into one network. Okay, because this one takes the first valid host ID here is 20.1, and the last valid host ID here is 20.255. So meaning when we summarize those all the networks, let's say router OSPF 10, then we want to give this router ID. Let's give them a router ID. Let's start 1.1.1.1. Okay, it's very important to give routers IDs, okay, for easy identification. Okay, so we've given that switch a router ID of 1.1. Okay, now let's advertise networks. How many networks are we going to advertise? For voice and for data and this connecting network. Okay, so let's start. The first network, let's advertise for voice network 10.10.10.0 wildcard mask of 0.0.0.3 area. Let's use the 0. Okay, the second network that you should advertise is this one that is connected directly. Okay, 192 network 192.168.21.16 wildcard mask of 0.0.0.0.3 area 0. There's something I went wrong. This one should not be this way. It should be .255 because you can see it here. Okay, so I'll just say no to that one to remove it first, and we correct it. Now I correct it to 255. And finally, the last network that you're going to configure to advertise is a summarized network of the 5. Okay, what's that network? That network is this one. If you summarize the 5 networks, we're going to get this one: 192.168.20.0, then 0.0.0.255. If you summarize all these networks, you're going to get this one. Okay, hit enter, exit, and do right. So let's advertise networks here also. Then first just write router OSPF 10, then router ID. Don't forget router ID, very important. 2.2.2.2. okay, router ID is kind of it's like a IP address 4 octets. Okay, that is 2-bit. Then we advertise networks. The first network is 10.10.10.0 wildcard mask of 0.0.0.255 area 0. Okay, another network is this one that is connected 21.20 21.20 192.168.21.20 wildcard mask of 0.0.0.3. hit enter. And finally, the summarized network of the 5, which was here was 255, and here was 0, and here was 20. Exit and do right. So let's go to this router also to advertise for the 1 network. Let's go to that router to advertise the 1 network. Exit, router OSPF 10, then router ID. let's give it 3.3.3.3. okay, and network, oh, it's only one, 10.10.10.10, oh sorry, that's 0, 255.255.255, welcome mask, 0.0.0.255, area 0, exit and do right. Okay, so we advertised the routes in this router, this multi-layer switch, this multi-layer switch. So we're done. We are only remaining with advertising routes on this router, this one, this one, this one. Let's do it very fast. So exit, router ID, router SPF 10, then router ID, very important. Let's make it 4.4.4.4. so that's just like a pattern. I made this one 1.1.1, 2.2.2.2, 3.3.3, now 4.4.4.4. okay, network, when we test this into this one, this one, this one, and this one. Okay, all right, so I start 192.168.21.16, 0.0.0.3, area 0. Then another network is 21.20, area 0. okay, 21.20, area 0. Then another network, you can see they are form adjacency. They should form two adjacency, that's okay, with neighbor of 1.1 and 2.2. okay, IDs, okay, for easy identification, very important. Now let's advertise this one, this one, very fast. So I change this to, it was 190.200.100.0. okay, then another one is .4, exit and do right. I've done SPF there, so let's do SPF on this ISP router. Exit, so router SPF or SPF 10, then router ID 5.5.5.5. network, let's advertise networks 190.200.100.0, this one, the direct connect network, this one, and this one. okay, and 0.0.0.3, area 0. okay, the form adjacency. Another one is .8. okay, exit, do right. .8 is this one, the one that's between this router and the server side router. Now let's do SPF on this router too. Very simple, SPF is the best one that we should use. So router SPF 10, then router ID, let's make it 6.6.6.6. then the network 190.200.100.4 and .12, 4 0.0.0.3, area 0. okay, I'll just enlarge this. okay, you can see it as form adjacency. And another network is .12. okay, exit, do right. Now let's go back to this router and advertise how many networks, 3 of networks, the direct connected networks, this one, and this one. So I go to this router, exit, enlarge it a little bit, router SPF 10, then router ID, let's make it 7.7.7.7. okay, then the networks are Let's advertise this one first. 192.168.2021.0. A wildcard mask of /28 notation is equivalent to 255.255.240. So 255 minus 240 is 15. So that becomes 0.0.0.15 area 0. Okay, and another network is dot 8 and dot 12. I'll do it very fast. Network 190.200.100.8 0.0.0.3 area 0. Then another network is another network is dot 12. Okay, exit and do right. It has not formed adjacency with the one router. Oh, it has done now. It has done now. So that's okay. Do right. How do we test if they form adjacency? For example, just go to this router here and just say do show IP OSPF neighbor. Let me expand and you hit enter, and you can see there are 4 neighbors: 2.2, 1.2, 6.06 and 5.5. okay, all right. So guys, we're done with the OSPF configuration. Now we can go ahead and check on the next step on the config guide. The next step on the config guide is the static IP address to server room devices, which is very easy. I'll do it very fast, save time, because we have seen that the default gateway of the servers at LAN should be IP address this interface, which is you can see it's a gig 00. IP address is 192.168.1.1/28. I mean, so email server. Let's email server to have. Let's start with the DHCP. I think. Let's start with the DHCP. Come to desktop. We come to IP configuration and 192.168.21. Let's make it around 25. Good. And subnet mask will be 240 because /28 notation. Okay, and the default gateway should be .1. Sorry, I think I'm making a mistake. Actually. The default gateway is .21 now, meaning DHCP should be .5. okay, .5, and DNS, I want DNS to be .6. okay, so I'll just copy this. Yes, not .21, not .20 something, is .5. okay, that's okay. We should respect the /28 notation, meaning there are only 14 IP addresses, but we gave out something like 20 something, which is above 14. So that's DNS I want is to be .6 I mean, and subnet mask, don't forget .240. DNS, I mean default gateway, that's that one, then that is just .60. DNS just .60. Let me try if it can reach default gateway. Ping. That's all. Web server, let's give it .7. Don't forget the default gateway, the subnet mask I mean, and this one is .6 DNS. Email server, don't forget. Let's give it .7 I mean, then 240. That one and that one 6. Okay, now everything is just okay, and we're done with that step. So let's see what's the next thing to do. The next thing to do is DHCP server configuration. Remember, we've been told here that DHCP server, all devices in the network except IP phones are expected to obtain IP address dynamically from dedicated DHCP server located in the server side site. Wow, very important. So let's go here and configure this DHCP server to provide IP address allocation to HQ networks. Okay, so what I do, just click on DHCP server, come to services, come to DHCP. The first thing, just have to turn it on and turn this to 00. You'll find some figures there, just turn them to 00 and save. Okay, all right. So, and also this one turn to 0, this one also turn to 0, and just save. Okay, now let's start creating pools. Let's start creating pools. This is the DHCP server. Okay, I bring it here. Let's start with HR. So for HR, I'll just say HR pool. HR pool. So for HR pool, the default gateway should be 192.168.20.1, because you can see this network. Okay, 20.1. DNS, we saw DNS was .6. DNS is the IP address of the DNS server that was located on the other side. Okay, now starting IP address 192, then 168, then here should be .20. Okay, 20, and we want to start it from, let's say 5. Okay, and the subnet mask should be /26 notation. So /26 notation is equivalent to 192. Okay, and the number of host devices, let's say 60, something like even 60. See, and we add. Okay, so that's HR pool. You see, HR pool has been added successfully. HR pool has been added successfully. So what's just remaining? Let's proceed and add other pools. For example, CS pool. So we just edit this, say CS pool, and the default gateway should start from 20.65. 20.65. DNS server remains the same. Then the start IP address, I want to start from, let's say 69 or 70. Okay, everything remains the same. I say add now. Don't say because it will override HR pool. Now add. You can see CS pool is given here. Okay, all right. So let's go back and configure MK. For MK, you can see this is the IP address, the network address, meaning default gate should start from .129. Okay, 129. Okay, DNS remains the same. Then starting IP address should be, let's say 135. Okay, subnet mask remain the same, and you don't save it, you will override. Okay, good. Then now we go back to LM department. LM department start from 20.192. That's the network. Now default gateway should be 193. Very simple, guys. 193. Okay, then when I scroll up a little bit, 193, DNS remain the same. Then let's start from 196, setting IP address. Then now here we've been told that the subnet mask is /27 notation. /27 notation is equivalent to 224. Okay, then this one was LM department, LM pool. Okay, and you add. So you see LM has been added there successfully. Okay, all right. Then let's go finally to IT pool. IT pool start from 224. Now 225. Now the default gateway should be 225. Okay, Now let's start it from, let's just say 230. Okay, subnet mask remain the same, and we add. Good. So guys, basically we are done with that one. We are actually done with that one. We are done with that one. So what's remaining is just to DCP server config. We are done with that one. Internet routing on all layer 3 switches plus IP DCP helper. Good. So it's upon us to go and do internet routing on these layer 3 switches, so that these computers here can be able to reach, can be able to communicate and also get IP addresses from this DCP server. Okay, so we're supposed to do internet routing for how many VLANs? 5. We don't do for voice because the voice gateway is just right here, so it's able to provide IP address to these devices. We only do for data 10, 20, 30, 40, and 50. So how do we do internet routing? We create sub interfaces. We create sub interfaces. Exit. So how do we create sub? We just say interface, because we already do show VLAN. We already have these VLANs, okay, the 5 of them. We don't do for voice now. We already have these 5 VLANs. So what to do? We create VLAN interfaces and assign them IP addresses. So the IP address that we are going to assign each VLAN interface should correspond to the default gateway of the respective VLAN. For example, the default gateway of HR department was 20.1. Now, because HR department belongs to VLAN 10, the interface of VLAN 10 should have IP address of 20.1. So for example, interface VLAN 10, okay, IP address should be 192.168.20.1. okay, subnet mask of 255.255.255.192, the subnet mask. Then we've been told that there's something here, interVLAN routing. There's something here under config guide. There's something here under config guide, plus IP DCP helper addresses. We are going to tell this interface, whenever you receive DCP discover messages from VLAN 10 hosts, then forward that message to the DHCP server. So I will just go here and copy the IP address of the DHCP server. This one, okay. All right, I close it and come back to this switch here. So we are going to tell it, if you find any host needing IP address, then forward that request to the DHCP server. So IP helper address to be IP address of DHCP server, okay, and hit enter, exit. Now we proceed to VLAN 20. VLAN 20, interface VLAN 20, and you assign it IP address of 20.65. IP address 20.65 and IP DCP helper. Very important. IP address of the other DCP server, okay, exit. Then we go to interface VLAN 30. IP address should be .129. You see there. Okay. Then IP DCP helper, correct. Good. Then we go to interface VLAN 40. Okay. IP address should be 193. Then the subnet mask is /27. Now it will become 224. I change this one to 224 because of /27. And then I come here and change it to 193. Okay. Then don't forget IP helper address, which is very important. Exit. Now we go back to the last interface of VLAN 50. interface VLAN 50, and IP address should be 225. Okay, 225, and PDCP helper address, don't forget, very important. Exit and do right. That's done, guys. That's done, guys. So let's write the commands on notepad and copy to this switch here. For example, I just want to copy something like this. Copy, no, just want to copy, where is the start one? Something like this for VLAN 10. Then I come here. So interface VLAN 10. That's how to write to do intermittent routing on a multi-layer switch. Then you assign IP address that to that interface. It should be .1 here. Okay, for VLAN 10, this one. Okay, and I copy, exit. VLAN 20 now becomes .65. Then don't forget IP helper address, which is very important. Exit. Paste .30, I mean interface VLAN 30. And VLAN 30 should be 129, I believe so. 129, good. And now VLAN 40 and 50. Exit. VLAN 40 and 50. Interface VLAN 40. It should be, sorry, it should be 193 now. IP address should be 193, but because the subnet mask is /27, this one changed to 224. Subnetting, very important. If you don't understand subnetting, I have already recorded a class that will help you understand it better. Copy, then you paste it there. Now VLAN 50. VLAN 50 should be 225. See here, 225. Copy everything, copy, and come here and I paste it here. Exit and paste. Everything okay. Exit, do right. So it's the time to test if DCP is working. It's the time that we go and test if DCP is working. For example, I'll go to this PC and change this to DCP. I'll close it. I go to this printer. I'll do it very fast, then come back and check. Okay, so it's the time that I go back and check if every PC in every department has picked the correct IP address. I start with the HR department. I'll hover and see, oh, they have picked IP address. You can see clearly that it has taken IP from .5, and the default gate is .21.1. I mean 20.1, and the DNS is unchanged 21.6. Also, let's go to CS department. Has it picked? Oh, it has not picked. Let me try to request again. Wow, it has picked now. You can see it has taken IP address in that range. Okay, default gateway is 20.65. DNS is unchanged. Let's go to MK department, see if it has picked anything. Wow, and MK has picked as expected. You can see it has picked IP address in that range, .135. Then this default gateway is .129. DNS is unchanged, 21.6. LM department, wow, it has picked. You can see 20.196 in that range. And default gateway is .193. The DNS is unchanged. And finally here on IT department, everything just working, guys. Everything is working, guys. Okay, because if I just click and you see desktop IP is DCP, I check it should be static and request again, it will still pick from the DHCP server. So guys, basically our DHCP server is working perfectly fine, and what's remaining is just to carry out with further configuration. What's the next step? Wireless configuration. Very important. So guys, I'll do wireless configuration on one device, then I do quickly on other devices to save time. So for example, this is HRAP. So I just go there and to config, you come to config, then click port 1. And let's say, let's name it HR, okay? HR. Then I copy that name. I come to password. You come to password and choose this one, WPA2 PSK, okay? You paste, and it should be 8 in length. 1 2 3 4 5 6. Okay, I copy that password, then I come to the laptop. I come to wireless 0 and I write the name as HR, and the password was that one. I close. I come to this one, come to this, come to wireless 0. Password, the host name was, the SSD was HR, and the password was that one that I copied. And they should pick IP addresses in that range. Well, 0. Okay guys, so I managed to configure all the access points and connect them to every host device, and the host device have picked IP addresses. So I believe we're done with that step. So I'll check on what the next step and proceed with it. Telephony service, very important guys, very important. So we're going to configure telephone service on this router. So I'll click on this router here, as I have said. Okay, all right, so just a minute. Okay, exit. And now I want to assign, first of all, we create a pool for the IP phones. Okay, pools for the IP phone. We create a pool by the name, let's say voice. First of all, service DCP. To enable that service, suppose it was disabled. Okay, then IP DCP pool, let's say voice. Okay, and then let's issue the network for the voice pool. Network is 10.10.10.1. dot 0. Then 255.255.255.0. Okay, default gateway, default router should be IP address of this interface, which was let me hover. It was 10. IP address of the sub interface that we created earlier. It was 10.10.10.10.10.1. Okay, then for IP phones, for creating DCP pool for IP phone, we issue something that is called option 150. Okay, 150. Then we issue this IP address. This is normally used for IP phone configuration, telephone service configuration. Okay, oh sorry, option 150, then IP. Let me query. Yes, IP, that one, and you hit enter, you exit. But now you can even do for DNS, let's say DNS for this one to be that IP address. Okay, then we exit. Okay, so basically we have created the pool for the voice, the IP phones. So what we need to do here is also to exclude the various number of IP addresses that we don't want that DCP server to assign to the devices. For example, IP DCP excluded addresses. So we don't want this router to auto assign the IP phones this IP address. Okay, and you hit enter. All right, so let's initiate the process of configuring IP phones, the telephony service. We just write telephony service, and then you issue maximum number of phones, max ephone, to be, let's say, just for a test, 20, even 30, no problem, 20. Then maximum number of directory to be created to be also 20, should be equal to the maximum number of phones. Okay, so you create number of phones to be 20, then number of directories to be also 20. Okay, all right. And now here you say what is called, you link it to the IP source. So you just say IP source to be the IP address of this interface, which was 10.10.1. okay, and you say port, they normally use port 2000. I'll enlarge this. Okay, normally use port 2000. Okay, and hit enter. And now you say just auto assign or 1 to 20. Okay, and you exit. Okay, so let's specify the ephone numbers. Let's specify the IP dial number. So let's say ephone directory number 1. So IP phone number 1 should have this dial number. We were told to use this format. Where is the VoIP configuration? We were told to use this format, 4 dot dot. Okay, so let this take 401. Okay, exit. Then the second IP phone to take 402, exit. The third IP phone to take 403, exit. The fourth IP phone to take 404, and do right. So with the time, this voice gateway router will be able to distribute IP address to all these IP phones in the network. So as you can see, they have picked IP address, so they have not picked the dial number. Although they have picked IP addresses, you can see they have IP addresses there. They have IP addresses. You can see clearly they have IP addresses, although the dial number has not come. So it's in the process. We just have to give it some time. This router here will be able to assign the IP phones the dial numbers with time. Okay, all right. So I'll just go back to the config steps, see what's next. Oh, the standard ACL for SSH. Remember, we've configured SSH in all the devices, and we can SSH from any of the devices. So we just want, for example, let me just test SSH. I want to test SSH on this router. So we just take IP address of that router, any IP address. Let's take 192.168.21.1. Then I try SSH from this laptop here, which is on HR department. So you just issue command SSH, then space -L, then the username that we created, we use Cisco, and then IP address that I've just copied. No, I just want it to be 192.168.21.1, and you see now Cisco, and this is server side router. Okay, we can configure it from HR department, any department, even on IT department we can do the same. But now we want a scenario where that it can only be done in IT department, because it's very risky that everyone can SSH to those devices. 192.168.1.21.1. Just give it time. Did that computer really pick the IP address? Why is it taking long? I'll just try to copy. Let me issue it again. I'll just try to copy. There's a problem in that laptop. Copy. Yes, Cisco. And you see. So we just want a scenario where the a search can only done from IT department in all the devices. So what I'll do, I'll just do it on only one device and copy on all other devices. So let me start with this device. I'll just demo here, or even this one. Okay, so this router doesn't want to assign the earphones directory numbers. Do reload. Yes. So meanwhile, let me start with this one to configure access control list. A standard access control list for securing SSH or the virtual interface. Okay. So what I do there, I will just say access list, let's say 10. Okay. Permit only this network. Okay, this network, only this network, which is 20.224/27. So access list permit 192, just a minute. Yes, 192.168. Just a minute. Good. .168.20.224, and we now issue a wildcard mask or just a IP address. So the wildcard mask 224 will be like 0.0.0.31. Okay, then you say access list 10 deny any. That's just okay. That's just enough, because we're now going to bind it to a VTY interface. We're going to bind access list 10 to VTY interface, meaning it's only this IP that will be permitted through the VTY interface. Okay. All right. So I want to test before I complete my configuration. I want to SSH to this switch. Let's take any IP address of that switch, which is we can just take any IP address, for example 20.1. okay, let us SSH from this laptop here. SSH -L, Cisco was the username, then IP address is 192.168.20.1. you can see I can SSH. Exit. Now I exit and go back and complete my configuration. Good. Then I'll come back later. Now I want to bind this access list to a VTY interface, access list 10. So just say line VTY 0 to 15, then access class 10 to be in, exit, and do right. We are just done. Now let's go back and try to SSH this one. I just try to SSH again and do right. You can see connection refused by remote host. That's the function of access control list on the VTY interfaces. So I'm going to try to SSH on from ICT department. This computer is bringing a lot of problem. This laptop, I tried it earlier. Oh, it didn't pick IP address. Okay, let it now pick it afresh. Good. Oh, it can't pick IP address. Let's use this one. Let's use that one. exit. What's wrong? Exit. It's not working. Good. Now let's SSH. You can see it's now working. Okay, so we are going to write commands on Notepad and copy paste to all other switches. So how do we configure a standard access control list for virtual interface? You first specify that access list 10, then permit this the only network that you've been told to do 20 192.168.20.224. a wildcard mask of 0.0.0.31. Okay, then access list 10 deny any. Okay, all right, so let's enter line VTY 0 to 15, then access class 10 to be in. Okay, exit and do right. I copy to all other remaining devices. For example, start with this one. Start with this router here. Paste it there. Oh, there's a problem. Access list. We should have a little bit of access. They should have an hyphen. Sorry, hyphen is very important here. Hyphen. Hyphen. Copy. Then I go back to this, and now I paste. Okay, now that's okay. Then I do for all other devices very fast save time. So let's meet later. Okay, so there was a time that I was trying to search on this router from HR department using this laptop. I want to repeat the same step. Exit. You can see connection refused by remote host. That's the concept of access control is. So that's done. Now port address translation. Port address translation. Very important now. So before configuring NAT, IP phones were not working, and now let me check if the issue has been resolved. Remember, I tried to I can see something good news here. I tried to reload this router. So whenever something doesn't work, just reload it or just save the packetizer file, close it, and reopen it again. Let me check if the IP phones have picked the dial numbers. Wow, that has picked. You can see it has an IP address and the dial number, and the IP address is corresponding to VLAN 120, as you can see there. Okay, all right. So even this one, good. This one is the first one that took. You can see it took dial number 401. What about this one? This one took 405. And what about this one? This one took 408. What about this one? This one took 404. This one took 4010. Wow, 410. I mean, oh, good. So I just want to test if the IP phones are working. I just had to ping from this one. Not ping, just to call. This one 406, and the other one is 410. I mean, so I put it here. Come here. Come with this one. Okay, and I want to call 406 from 410. 406 and call. You can see this one is calling. This one is ringing. Okay, and we can pick up, and you see now they are connected. We can hang up, and now let's try to call 410. 410. You see this one is ringing, and we can pick up, and you see all are connected. So let's proceed to configure our port address translation. So we are going to use port address translation on this router here. Okay, on the HQ router. So while configuring NAT, we have to identify which interfaces are NAT inside and NAT outside. So for example, this one and this one are NAT inside, while the outgoing interface are NAT outside. So I'm just going to configure that very fast. This one is a gig 00 and gig 02, gig 01 I mean. So interface range gig 0/0 to 2 to 1 I mean. Okay, IP NAT inside. Okay, exit. But the two interfaces above, this one is serial 021 and 020. So interface range serial 0/2/0 to 1. Oh, there's a problem in the serial, so just write 020. Oh, serial interface. Where's the problem? Serial 020 interface serial 020. Okay, IP NAT outside. Then 021 also IP NAT outside, exit. So let's create another access control list to be used during NAT. Okay, so we want to create another, let's say we want this router to translate the internal network, which is when we summarize all these networks, the 5 networks we were getting. So we just say access list. Now let's use this one as 50. Okay, access list 50 permit this network. This is the summarized network .168.20.0 then 20 then 0.0.0.255, the summarized network. Okay, this network represents all the 5 departments. It's the summarized network of the 5. Okay, so this is the access control list to be used during NAT. We're going to use PAT. PAT is port address translation or NAT overload. So let's bind the access control list to NAT. Okay, so we just say access list 50, it's 50. Okay, then access list 50, sorry, I'm saying let's bind this access list to NAT. So we just say IP NAT inside source to be for the access list. Okay, because the access list is permitting this one. So source is 50. Okay, 50. Then we say source is access list 50. Access list 50. Source is just a minute. Source should be list 50, not access list. Yes, list 50. Okay, then we give the interface, then interface we can say serial 020 overload. Okay, you can say serial 20 overload. Okay, or even this one 021 overload, because those are the outgoing interface. Okay, so the first thing you create interfaces as NAT inside, NAT outside. Then you permit, you create the access control list, then you bind the access control list to NAT. So do right. Okay, so I'm going to try to ping DCP server, or just sorry, I'm going to try to ping any host that is that the traffic must pass through this router. Let's say even the IP address of this router, or even the mail server here, 21.8. So I want to ping 21.8 from this PC here. Ping 192.168.21.8. So just give it some time, it will ping. It will ping. It should ping. Good. So that's just enough for us to test NAT translations. So we just go to this router here and say do show IP NAT translations, and hit enter. And as you can see, we've pinged from which PC? We've pinged from which PC was this one? It was this one. Okay. It was pinging 21.8, and the IP address of that PC was 20.75, and now you will see it here. ICMP passing through this router, then the inside local is the IP address of that PC, then outside local is the IP address of the destination plus the outside global. So this is the NAT translated IP address. It has taken the outgoing interface and assigned port number. So very, very important, NAT is working. So let's go ahead and check what's remaining. Site-to-site IPsec VPN. Guys, site-to-site IPsec VPN is one of the most challenging part in packet configuration, and I'll show you how to configure it. So the first thing we want to understand is the security part of it, because we've been told that the HQ network should, any packet from HQ network to the server department should be encrypted. Okay, now because the traffic is passing through the SP routers and they are unencrypted, you know, someone can sniff and read the content. We don't want a situation where our traffic is hijacked at the SP zone. Okay, we just want them to pass through SP zone encrypted. So that's why we must configure site-to-site IPsec VPN between this router and this router, such that any traffic from this router, from this network to this network, is encrypted, and also from this network to this network is encrypted, so that no one can interfere with the traffic, right? So I'll just do this. So IPsec VPN will create a secure tunnel and encrypt any data that is passing through this router to this router. Okay. Alright, so let's embark on configuring IPsec VPN, which is one of the most challenging part. So as I always do, when I find something challenging, I normally write some codes on Notepad and share. Okay, so I have already written some commands on Notepad for IPsec VPN. So just go to that directly, and so if I can just open the code. So these are the commands that I use to configure IPsec VPN between the routers. So this is just the command for one router, which is the SQ router. The first thing that I did was to create an access control list. Okay, an extended access control list, and you permit to specify the interesting traffic, which is from the summarized network to the server-side network. Okay, that's for HQ router. Then you create policy, crypto ISCA map policy. Then with the encryption algorithm of 8 AES with the length 256. Then authentication to be pre-shared, and the Defi-Ellman group 5. Okay, then you exit, and now here you create a crypto ISP map with the key. You specify the key, the pre-shared key, and the address to be IP address of the server-side router. So it's a little bit challenging, but that's why I decided to write them, because I can't master all of these commands in my head. And now you create a transform set, and you name it to use these parameters, and you create a a crypto map, okay? You name it to use IPsec ISAC map, okay? Internet Security Association Key Management Protocol. And then you give a description of that VPN, for example, connection to server side. Then you set peer. The peer should be the same as this address. The IP, any IP address of this router, the one that is outgoing, okay? For example, for this one, right? Now another thing that I need to explain there, now you associate that crypto map to the outgoing interface, okay? So in this case, our outgoing interface should be any of this, but I've decided to use 2020, okay? So I'm just going to copy, these commands and paste in all these routers. And before I do that, guys, by default, the 2911 routers, they doesn't have a security key module. So it's upon us to import the license. So you just have to go to that router and exit, and we just say license boot module C9. The version of the router, you can see it's Cisco 2911. I mean, then technology package to be, just a minute, technology package to be security K9, okay? Security K9, very important. And you hit enter, and it will ask you this: do you want to do that? Yes, I want to activate the security license. I say yes, and you hit enter. And now we have to give it some time. We say do reboot, do reload. Yes. So we go back to this router also, because we want to only implement IPsec VPN on this router and on this router. So we do both for both two routers. Exit. Let's enable the security license module. So just say license boot module C9. Then you say technologies package to be security 9, okay? And you hit enter, and you say yes. And next reboot level, okay? Now just do reload, sorry, and yes. Okay. So I can proceed to configure to paste all these commands that I have configured here, that I wrote earlier, okay? So I can just copy all of them. Then I come to this router here and say exit, and I paste. So everything is just working perfectly fine. I didn't see any error. Now I have configured IPsec VPN on this router. I'll proceed to configure IPsec VPN on this router. So what I'll do, I'll just modify this configuration. For example, the access control list should now be from server side to HQ network. So I just remove this one, this side, I remove it that side, and I take it this side. So it's from server side to HQ, okay? Then we come, only what we change is there and also here, okay? IP address now should be IP address of this router, the outgoing interface, the one that we wrote. It was 200. The IP address of 020. IP address of 020 was 190.200.100.1. So I change it there, 100.1. So if you change it there, make sure you change it here, okay? And also description, change description, VPN connection to HQ network. So that's just enough. Because we still want to use this outgoing interface, okay? All right, so I'll just copy and come to this router, and I paste. and that will mark the end of IPsec VPN configuration. Good. So that marks the end of IPsec configuration. Okay guys, so I'm glad we've configured everything as expected under this config steps, and we have verified and tested everything. So thank you so much for paying attention to my video, although it was a long video, but I'm glad that if you follow it to the end, you've learned a lot. And suppose you have any queries, you have any doubt, kindly let me know in the comment section. Please, if you need this packet tracer file, join the channel membership, and don't close the video before you subscribe to our channel. Share our videos, encourage us with comments, and visit our website to see more projects. Thank you so much, and let's meet again when we are going to handle the 10th enterprise network project.